Hi, and this is Software Testing from Scratch, brought to you by Eduonix. My name is Richard Martin, and this is Chapter 1, What to Test and How to Test it. We've got a breakdown here of the topics that we're going to be covering. Good test coverage, determining test oracles, defining test procedures, configuring the test system, operating it, observing it, evaluating the test results, and getting a good report together as well. So firstly, what is code coverage? In order to perform code coverage analysis, you need to do a code review. And this is usually the first battle. It's trying to get a developer to show you their source code. Not only would it highlight potential issues, but bad coding practices too. Most developers are of the mindset that if it works great, who cares how it looks? In reality, that can cause a lot more problems down the line when it comes to troubleshooting. Normal test scripts are scripted around requirements or a features document. If there are any underlying functions within the application that aren't documented, this is definitely going to be an area of concern, and it would also stop you having a full test coverage as well. So a good example of this would be if an application is only advertised as having a nightly job archive, but upon the code review you can see that it's using a combination of a few different applications, cron, logrotate and syslog. You can then add in extra tests to test all three of these applications as well, simulate failures, that kind of thing, rather than just the application on a whole. It may react differently if a certain section or a certain portion of the back end of that failed that you didn't know about just by reading the features or requirements document. So here's a bit of a code sample here to give you an indication of how you do a good test coverage with code. So firstly, if during this execution the function foo was called at least once, then function coverage for this function is satisfied. Statement coverage, however, for this function will be satisfied if it was called, as example, foo 1, 1, as in this case every line in the function is executed using z equals x. Tests calling 1, 1 and 0, 1 will satisfy branch coverage because in the first case the two conditions are met and the x equals z is executed, whilst in the second case the first condition is not satisfied, which prevents executing z equals x. Now finally, condition coverage can be satisfied with tests that call foo 1, 1, foo 1, 0 and foo 0, 0. These are necessary because in the first two cases, x is greater than 0 evaluates to true, while in the third it evaluates to false. At the same time, the first case makes y is greater than 0 true, whilst in the second and third it makes it false. Now each part of this code would definitely warrant its own test case, just to try and test the bounds of the code. Again, you wouldn't get this kind of detail if you were just reading from a requirements document or a function document written by the developer. So next we have fault injection, which is a process of intentionally trying to cause errors outside of the documented error handler. It gives a more exhaustive test coverage. It allows you to speculate about unexpected conditions the application may encounter. Just because you've done your use case, it doesn't mean that that's going to be exactly what happens in the real world. So this will test how the application handles an error. It shouldn't have a traditional unknown error message provided by Windows. It should be formatted by the developers, so not to cause any undue panic by the user who may think they've broken the application. If the user gets an error message popping up that's got a strange error code in it, maybe even a snippet of code as well saying something wasn't recognized, the first thing they're going to do is get on the phone to tech support. Now next on the list we'll have stress testing. It's another good form of fault injection. Just because an application is doing things correctly with just the tester performing activities, it doesn't mean it will if there's 500 people all trying to call the same routine at the same time. We'll cover some more stress testing applications in future chapters when we look at testing tools, but that's definitely one of the best methods of fault injection you'll come across. Next we have fuzzing, which is the process of injecting unwanted or random data into the application input streams and looking for some kind of adverse effect. A good example of fuzzing could be trying to add an extra layer of encapsulation onto a packet before it's received by the program. how does it handle it? Does it handle it? Does it crash? Does it give any unknown errors to the user? We'll be covering network fuzzing a lot more in the security section. It's quite rare for a standard QA team that aren't doing any kind of security testing to use fuzzing as a method of test. This is a really simple example of fault injection. The application accepts integers between 2 and 7. The user or the tester will then enter number 9 to see what the effect would be. Ideally, the effect should be a crafted rejection, not only to stop it causing issues with the application, but also to inform the end user that their selection was invalid and the application has dropped the request. How do you ensure that the test meets the test quality and coverage needs of the design, especially in common situations where the board designer and the test developer are from two different companies or even two different sites? Well, test coverage measures the amount of testing performed by a set of tests. Wherever we can count test items and can tell whether or not each of these items has been tested, then we can measure coverage. This is known as test coverage, which is essential for a test report. This is the mathematical formula used to work out the coverage percentage. So coverage equals number of coverage items executed over total number of coverage items times 100. So an example would be 90 test items executed. There's 100 items in total times 100 equals a 90% coverage. Quite often in test reports, not only do you need to provide the raw data of which tests have been completed, which ones have passed and failed, but you also need to provide a rather high level report of this is the percentage of tests on a particular application. 9 times out of 10, in my experience, the people who read the reports don't go further than the summary unless there's problems, and then they're looking at who they can blame in testing and then in turn who they can blame in development for not spotting a problem. As long as you've got your evidence there's no reason why your front page shouldn't just contain percentages of items executed, etc. So who's ever heard of a test oracle before? Before I'd started testing, I'd never heard of it. This is basically, did the test pass or fail? I'm going to give you a definition as well as advantages and disadvantages of each of these oracles. So a true oracle is an independent generation of all expected results. If there are 10 expected results, a true oracle will exploit one of them. The advantage is that no encountered errors go undetected. However, it's expensive to implement. This would mean a 100% test coverage. It's complex and often time-consuming when run. Next we have a heuristic oracle. It verifies some of the values as well as consistencies of remaining values. It's good because it's faster and easier to run than a true oracle and is much less expensive to create and use. However, it can miss rather obvious issues as well as any systematic problems. A sampling oracle selects a specific collection of inputs or results. Its advantages are that it can select easily computed or recognized results, and it can manually verify with only simple oracle. However, it may miss systematic and specific errors, and it often trains the software to pass the test. A consistent oracle verifies the current run results with a previous run, which is regression testing, which we'll cover later. It's good because it's fast. Its verification is very straightforward. It's comparing previous results. It can generate and verify large amounts of data on the fly. However, the original run may include undetected errors. If you're comparing your current test against a previous regression test, which is flawed, it's completely pointless. So the document that you use to define the test procedures and methods needs to contain the following. It has to have a descriptive title, usually containing a company and project name. Sorry, just before we continue, you'd be surprised how many people don't know how to write a report, and their report is 10 lines on an email to their boss saying that something works. If you need to cover your own back and you need to ensure that everything is documented, you need to define everything you're going to do. Not only, as I say, to cover your own back, but to make sure that the customer is going to be satisfied with the result as well. So anyway, sorry. The scope of the test subjects. What are you going to test? What are you not going to test? The dates of software versions is fairly self-explanatory. Next, who's going to test it, where are they, and who will be looking after this test from a management perspective. If you need to deviate from any of the tests, you're going to have to clear that with management first, because if a tester takes that on his own shoulders and it ends up causing issues further down the line, you don't want to be held responsible for that. The terminology. A lot of people don't know what TCP and UDP mean, and if you're going to include that in your test report, give some kind of reference for it. It'll save a lot of questions in the long run. The significance or importance of the test. Why did you choose to perform several unit tests rather than a full system test? Did you use a black box or white box approach, and why? We'll cover black box and white box testing later. And also you have to list your apparatus as well. Did you use an iPad mini, an iPad Air? What load test tools did you use? Safety precautions. As far as software testing goes, if you've got the actual equipment on your desk, the only safety precautions you're probably going to go for are each member of the team must wear an electromagnetic or ESD wristband. Environmental considerations. Just because you can replicate the test environment doesn't mean that it's exactly the same. So an example would be that you're only able to replicate 100 megabytes per second in the test lab, whilst in the real world it could be 150 or 200. In result sampling, if you need to look at 10,000 data samples to get a result, how do you choose which one to interrogate in order to get your result? And preparation of test data. Do you need any test or simulation data in your environment to make the test more accurate? If you're testing a large network, it might be handy if you can simulate having 100 users on the network while you're performing your tests, just to see how the various applications handle under load. And finally, it should be that detailed that you will say, I will perform test number 1, followed by test number 2, witnessed by colleague X, let's call him Tom, and I will attach the debug log as evidence of the test being performed. Next we have calculations and analysis of data. This kind of goes back to the how do you choose if the test passed or failed if you're interrogating 10,000 units of data. Do you need any other tools to look at the data? If you've been measuring say a throughput application, do you need any further network analysis to determine the test results? Do you need to copy and paste large amounts of data into some kind of number cruncher to determine the result? And next, the report format. It's usually a business template that's been agreed previously to the test. However, I will include a template test procedure with this presentation. Now, configuring the test system. Ideally, you need to replicate the live system as best you can. So you need to have documentation of a live system, usually prepared by the engineers or the system administrators who are implementing it. Not only do you need this documentation, but it would be great if they could look at your system and verify it's been set up correctly once you've done it. The last thing you want to do is spend 2 weeks testing, get to the very end, and realize you've left out a major component of the network. So debug information. It's a good idea to have as much debug running as you can, hardware providing anyway, because if you were to encounter an error, there's no saying that you wouldn't be able to reproduce that error again in the future. So if you've got some debug log running, you'll capture an error there and then, and you can interrogate it immediately. And platform separation. Although ideally customer networks and test networks should be segregated, sometimes that's not the case. So if you're going to run any massive load through the application, make sure it's on a separate platform and it's not all virtually hosted on one bit of hardware, or even make sure that it's not on the same network as well, so you're not going to be hogging any bandwidth. And the best thing about testing is that if we break something, which hopefully we all will at some point, you should be able to roll back as well. You don't want to be rebuilding an entire test system just because you broke something. In my experience, the best test system would be virtualized. It'll give you so much independence over an actual bit of hardware, not only for failures and that kind of thing, but generally administrators will be a lot happier you having root access to a virtual machine than they will an actual bit of hardware. This does go back to rollback and snapshots and backups and that kind of thing. because you're just going to create a headache for the rest of the team if you destroy something during a test and you don't have that point of rollback. Which again is also why it's important to have root privileges on the application as well. You don't want to be performing everything from a user's perspective. If you're going to be interacting with applications, you want to be doing it from a root level, just to make sure that every subroutine is being run and everything is being allowed. If you do run it as an underprivileged user, chances are it won't be doing everything to its full potential anyway.